Okay, what is the difference between 2 times 2 and then 2 cubed? 2 times 2 times 2. You get the idea? Okay, so 2 squared is 4. What's times another 2? 8. What's times another 2 after that? What? 16. Okay, then times by 2 again. What do you get? 32. Then times by 2 one more time. 64. Now, I only need you to find the ones I'm not Xing out. You're never going to use those 3. The numbers get really big. Okay? So, let's start with 3 for our next one. 3 squared is 3 times 3. What do you get? 9. Okay, so put in 9. Then I times by another 3. What do I get? 27. Then I times by one more 3. That'd be 3 times 3 times 3 times 3. What are these two together? 9 times another 9. 81. Okay, so if there are 4 of them, I can do 3 times 3 is 9 twice, and then times the 9s together. Okay, let's do our 4 column. 4 squared, what do you get? 16. Okay, now times that by another 4, what do you get? 64. One more. What is 64 times another 4? 256. Yes. Okay, let's do 5 squared. 5 times 5 is? 25. What about times another 5? 125. Okay, and now times by one more 5? Wow. Are you all typing it in, or you just know these? Good. Okay, let's do 6. 6 squared, what do you get?
36.
Times by one more 6? 216, right? I think. 36 times 6, what do we get? Do y'all have a calculator? Anyone?
160. I mean 216.
Okay, it is 216. Okay, now we need to times by one more 6. So the next one would be, oh, that's too big. Exit out. Yeah, it's 1296. But you won't have that one that big. Anything above 1,000 you can just cross out. Okay, let's do our 7s. What's 7 squared?
49.
What's times another 7? 343. Very good. Okay, next one. 8 squared is? 64. And then 64 times another 8. What do we get there? 64 times 8 gives me 512. Good. Okay, and 9s. What's 9 squared? 81. Then what's 81 times one more 9? Very good. Okay, then the last one you can leave it off. 729. Okay, now your 10s are easy. 10 squared is 100. Times by another 10, what do you get? 1,000 times by one more? 10,000. Okay, so you will get to use this chart whenever you're solving exponentials. Okay, eventually, hopefully, you'll sort of memorize them, but we're not going to like have a memorization quiz over it. So for right now, this is your chart you're going to use to convert. Okay, so we're using this to solve. So here's what you're going to do. You're going to rewrite both sides as a common base. Common base. That means your bases on both sides have to be the same. Now, once you do that, like bases are going to cancel. And you're going to set only the exponents equal to each other. So you're going to get a common base on both sides. You're going to cancel the common base out and then just let the exponents be equal. Okay, and then from there, your little hole punch number 3, you're going to solve. Okay, so we should not have to do every question on these notes. They're kind of long because when you were in Algebra 2, you should have done this for like 3 days. So none of this should be new, but we're going to review it before we get into logs. So look at number 1. First question, do I need to get a common base or do I already have a common base? They're both 2s, so cancel the 2's out and then bring down the exponents. So I'd have 2x from this side equal to 10 on that side. And then from there, what do I do to solve? Divide by 2, x is what? 5. Easy, right? Okay, let's go to number 2. So notice I have 2 to the x times 3. Well, that's the same as 2 to the 3x. But then 64 needs to find a common base with 2. So I'm going to look in my chart here. 64 is right here. How can I write that as a power of 2? 2 to the 6. And then once I write them both as a base 2, I can cancel it out. So cross out your 2 here, cross out your 2 here, and I have 3x equals 6. Yes?
Miss, even this 4 to the power of 3, we still get 64. We don't put that with 2.
Yes. Okay, so she brought up a good point. So she said that 64, look right here, is also in the 4 chart. But if one side's a base 2 and one side's a base 4, I can't cancel them out because they're not the same. So if your base here is a 2, you need to look in the 2 chart to match your 64. Okay? Alright, then from there, divide by 3, what's x? 6 divided by 3 is 2. Good job. Okay, look at the next one right next to it. I have 7 to the 2x on the left. So 49 I need to rewrite. What is 49 as a base 7? 7 squared. Now, the exponent that was already there, you need to keep together. So if it was an x plus 3, I need to keep the x plus 3, but I need to parentheses it together to show that the 2 is coming in new, but the x plus 3 was already there. Then from there, what do I do with my 7 since they match? Cancel. 2x equals, right side, we're going to distribute the 2 into the original exponent. So it's an x plus 3 times by 2, now it's a 2x plus 6. From there, I have x's on both sides, so I'm going to minus this 2x across to the other side. What do you notice happens, though, to your x's if you had 2x and you minus 2x? Cancel, so you get 0 equals. This side, they cancel, 6. Now notice, all your x's are gone. That means it's either infinity solutions or no solutions. Are 0 and 6 really equal?
No.
So I put no solution. What if I had gotten 6 equals 6? Infinity solutions. That really is true. Okay? But that's only if all of your x's on both sides cancel out. Okay, come down to the bottom row. We are going to do number 6. Okay, take a look at number 6. I have a 25 on this side. I have a 5 on this side. Can I rewrite 25 to be a base 5? 5 what? 5 squared. X minus 3 gets kind of parenthesesed off. And then 5 to the 10, they already did it for us. Then I take my common 5s, slash them out. So this 5 are gone. What do I do with the 2? Distribute, and then bring it down. Very good. So 2 times x is 2x. 2 times minus 3 is minus 6. And then only the 10 comes down. The 5 canceled out, but the 10 you bring it down. Next step from there, what do you do? Add the 6 across. What's 10 plus 6? 16. Last step. How do you get rid of the 2? Divide. Do you remember this from Algebra 2? Yes? No? Maybe? A little bit? Yeah. Alright, turn the page. So there are several special cases, and we're just going to kind of go through each one. Like I said, you learned all this hopefully in Algebra 2 over a couple days. But the next one is going to be when you have a 1 on one side. So, ready? Good to turn? Okay, so take a look at number 7. Whenever you have a 1 on both sides, that is any base to the power of 0. So for example, if I'm doing number 7, my left side, my base is a 9. 9 to the x minus 6. Well, then my 1 needs to convert to be a base 9 as well. 1 can be any base to the 0. Now, if you're not sure about that, type it into your calculator. Anything to the 0 is the same as 1. So we're going to use this special rule right here. Anything to the power of 0 is 1. Then if I have a 1, I can use whatever base I want as long as I put a 0 on it. So from there, my 9's cross out. I have x minus 6 equals 0, and then how do I solve it?
Plus 6.
Plus 6 plus 6. So x equals 6. Make sense? Okay, so real quick, switch to your homework for me. Find the one where you're going to use a 0 exponent on it.
3.
Number 3. Now, if you're one of those people that you kind of watch the notes and do the homework, you are only going to do the odds. Okay? So if you just started, you're only doing even. So if you want to go through and cross them out, that's fine. Okay, but I don't want you, if you're working on it, to get like halfway through and you did every question.
I just did 8 questions.
Oh, wow. Now, if you want to do all of them, I'll give you extra credit or something. Okay, if you want to just keep going with it. Okay, so number 3, how would I rewrite this one? 3 to the what? 0. So I'd make it 3 to the 2x plus 6, and then 3 to the 0. And then from there, are you good to solve it? Okay, back to your notes. So the other option is, let's say that you have a number that doesn't have a base on it at all. So for example, number 8, I have an 8 on this side, I have a 2 on this side. So can I convert 8 to be a base 2? Look at your chart. What is 8 as a base 2? 2 to the 3. So I'm going to come back over here and I'm like, okay, well this is 2 to the 3. X minus 2 sticks together, but then my 2 doesn't have a number on it. If no base is listed, that counts as a base to the 1. So if no base is, or no exponent is given, that counts as a 1. So I'm going to put a 1 right there. So that when I cancel the base 2's out, I have something left from that side. So gone, gone. 3 times x is 3x. 3 times minus 2 is minus 6, but then equal to 1. So you have to leave something in that place, or else you end up with nothing there. Add your 6 across. What's 1 plus 6? 3x equals 7. Last step. Divide by 3. Now, 7 will not divide evenly by 3, but I can just leave it as a 7/3. Okay, and that does happen. There are a couple of them that come out to be fractions, so no big deal on that. Okay, any questions about that? Okay, next section. When you have an exponent on the bottom, do you remember how you move it up to the top? What do you change on it? You turn it negative. Do you remember that? So like if I have an x squared on the bottom, that's really an x to the minus 2. So if I'm doing, let's say, number 10, we're going to skip number 9. We'll come back to it. 64, look it up on your 4's chart. Okay, make sure you're keeping the same base. So I'm going to come over to my chart. 64 is 4 to the what? 4 to the 3rd. So I have 4 to the x minus 1 to the 2. And this is 1 over 4 to the 3rd. But then I don't want it as a fraction. So to undo the fraction, when I pull this up, I'm going to turn it to a 4 to the minus 3. Okay, so I'm going to put fraction turns the exponent negative. Okay? You can just leave it over there. I'll find it. Is that your homework? Yeah, you're good. Okay, and then on the other side, I have 4. X minus 1 sticks together, and then a 2 to the side. Now that they're both base 4's, I don't have any more fractions because I turn the exponent negative. I can cross the 4's out. And what do you guess we're going to do with this x minus 1 and the 2?
Put it down.
No, we're going to put it down and distribute. So I'll have 2 times x is 2x. 2 times minus 1 is minus 2. And then on the other side, we still have our negative 3. Then from there, how do I get rid of a minus 2?
Plus 2.
Plus 2. Negative 3 plus 2 gives me negative 1, then divide by 2. And negative 1 won't divide by 2, so I'm just going to leave it as a fraction. Make sense? Alright, next one that we're going to do, let's do number 9. Okay, look at it. 16. Now 16 pops up in 2 charts. Do I look under the 2 chart or the 4 chart? 2. Why 2? That's correct. Because it's a 2 on this side. And I have to look it up in the same chart base that I already have. So what is 16 as a base 2? 2 to the 4, but it's a fraction. So instead of putting 2 to the 4, what will I put? 2 to the negative 4. Does that make sense? So if it's a fraction, then you have to turn that 2 to the 4 into a 2 to the minus 4. And then from there, my 2's cross out. Negative 4 times 5 gives me what? Yep. And then if that's equal to 4x, how do I get rid of the 4? Divided by 4. What's negative 20 divided by 4? Negative 5. Okay, I'm going to give you one more like that to do. Do number 11. So I have a 9 on the bottom. What power base do I want it to have? 3. So look up 9 in the 3 chart. 3 to the 2, but then how do I show it was a fraction? 3 to the minus 2. Yeah? So remember that 9, this is 1 over 3 squared, but then I have to turn it into a 3 to the minus 2 because it was a fraction. Okay? Then from there, my 3's cross out. What do I bring down? Negative 2x equal to negative 8. And if I divide by negative 2 on both sides, will x be positive or negative? Which one? 2 negatives make a positive 4. So I do 8 divided by 2 is 4, but then the negatives cancel each other out. Make sense? Okay. Next section. So we're going to skip 12. Hopefully you get the idea. Okay, number 13, 14, and 15 are called non-compatible bases. This is what that means. What base do I want to use for the 27? A 9. Look on your 9 chart though. Is 27 in it? No. So what you have to do instead is lower both bases to find the common base. So what chart are 27 and 9 both in? The 3 chart. So if I can't find 27 in 9's chart, then I'm going to use the base 3 chart. Okay, and again, why? Because both of those numbers are in that chart. That's how I can give them the same base. So let's look up 9 and 27. Hopefully you already have it. Okay, 9 is what? 3, 2, and 27 is 3, 3. So let's come back to our paper. 9 is going to be 3 to the 2. What do I do with the x plus 3? Put it in parentheses. Then 27, that's 3 to the what? 3, but I had a 2 left over. And then from there, I can cancel my common bases. So this 3 and that 3 are gone. On the left side, 2 times x is 2x. What about 2 times 3? Other side, 3 times 2 is also 6. And then I keep solving. How do I get rid of my plus 6? Minus it across. And what is 6 minus 6? 0. Okay, now I was about to ask, is this a no solution? No solution is when your x's cancel out. Do I still have x's left over? Yeah. How many? 2. Then I got to keep solving until I get x by itself. So 0 counts as a number. What cannot happen for a no solution is when your x's are gone and you have nothing left to solve. So divide by 2. Can I divide 0 by 2? Yes. What's 0 divided by anything? 0. Okay. We'll do one more from this section. We'll do number 14. So look at 16. Can you find 16 in the 8 chart? Nope. 16 can't turn into a base 8, so I have to look for a chart they're both in.
4.
Is 8 in the 4 chart? I don't think it is. Let's look and see. 8 and 16. Okay, yeah, so look at my 4 chart. I have the 16, but I don't have an 8. So I have to go back even smaller to the 2 chart. Does that make sense? So you're just looking to see they have to both be in the same chart. So 8 is 2 to the 3, 16 is 2 to the 4. And then I'm going to flip back and I'll rewrite it. So 8 is 2 to the 3, 16 is 2 to the 4. So I have 2 to the 3, 2x minus 1 left over, 2 to the 4. 2's are going to cross out because it's on both sides and they're the same. 3 times 2x is a 6x. And then 3 times minus 1 is a what? Negative 3 equal to 4. Because remember, the 2 crossed out, so only the exponent's going to come down. From there, how do I get rid of a minus 3? Add it, plus 3 and plus 3. 4 plus 3 is how many? So 6x equals 7, last step. Divide by 6. And then remember, if 7 can't divide it by 6, just leave it. Okay, no big deal. Now, number 15, we're not going to do it, but we're going to rewrite it. So look at your charts, flip back. Is 32 in 4's chart? No, but what chart are they both in? Okay, they are both in the base 2 chart. So rewrite it, we'll check it, and then we're going to move on. They're both in the base 2 chart. So 4 is what? 2 squared, x stays up top. And then 32 is 2 to the what? 5, and then x minus 8. Does that make sense? Okay, and then I'm just going to put etc. ... Okay, and then you know what to do hopefully from there. Okay, turn the page. There are 2 more special cases that we have to look at. So the next special case is, what do you do when you have 2 things that are multiplied together that have the same base? So here's my example. If I gave you, don't write this down, just look. If I gave you a squared times a to the 7, what do you do with the little numbers? You add them, so that'd be a to the 9, right? So whenever you have like bases here, where they both have 9s, you're going to group that into 9 to the x plus 2. So whenever you have 2 things with the same base, for example, they both have 9s, you're going to combine by adding the exponents. Now, 81 needs to be converted. So look back at your 9 chart. What is 81? 9 to the 2. And then from there, I can cross out my base 9s. X plus 2 equals 2 comes down, and then what's my next step? And what's 2 minus 2? 0. Does that mean no solution? No. 0 is a number too. Sometimes it's the answer. Okay, so remember, 0 is allowed to be the answer. Okay, take a look at number 17. I have 5 to the x times 5 to the 4. What do I do with the exponents? When I combine, it'll be 5 to the x plus 4. So remember, you take these little numbers and you add them together in the exponent because they have the same base. Other side, 125, look it up in your chart. 125 is 5 to the what? 5 to the 3rd. Okay, and I'll show you right here. You just look up 525. 125 is here. That's 5 to the 3. Okay, from there, my like 5's cross out. X plus 4 equals 3 comes down. And then what's your next step? Subtract 4. 3 minus 4, what do we get? negative 1. Good? Okay, take a look at number 18. Now notice, 18 is where you add an extra step. Are 16 and 4 like bases that I can squish them together right now? No, they need to find a matching base. So can I write 16 as a base 4? Yes, 4 to the what? 6, so what is 16 in your 4 chart? Yep, right there, see it? 16 is 4 to the 2 times x, and then 4 to the 1. Let's convert 64 as well. What is that as a base 4? 4 to the 3. Now, from here, what do I do if I have 2 base 4s? I combine them by adding the exponents. So I would have 4 to the 2x plus 1. Does that make sense? So if they both have a base 4, I just make them a single base by adding their exponents together. And then from there, cancel out your 4s, keep solving. So this 4 is gone, this 4 is gone. 2x plus 1 equals 3. What's my last step, or my second to last step? What do I do with the plus 1? Subtract 1, subtract 1. My 2x comes down. What's 3 minus 1 left over? 2. And then last step? Divide by 2. 2 divided by 2 is 1. Okay, one more left like that. We're going to set it up, but we're not going to finish it. Okay, I want you to find a common base for 49 and 7. Because I need them all to match for me to do my combined step. What's 49 in your 7's chart? 49 is 7 squared. I can see it right there. So I have 7 to the x times 7 to the 2 equals 7 to the 12. But then remember, I can only combine these if I add the exponents together. So 7 to the x times 7 to the 2 is 7 to the x plus 2. And then from there, you would take your 7s, cancel them out. So what would be left over? X plus 2 equals 12. And I guess we might as well finish it. How do you get rid of the plus 2? Subtract it across. So minus 2 here, minus 2 here. 12 minus 2, what do you get? 10. Nick, did you have a question? Huh? Okay, so let me actually, somebody asked the same question. He said, how do you know that it's x plus 2 and not 2x? Here's the difference. If it was this, that would be 7 to the 2x. So I multiply when only one of them has a base. But if they each have their own base, that's when I add. Do you see the difference? This I multiply. These two I have to add. And it's because each of them have their own 7 when you add, versus here they're sharing the same 7. Does that help? Okay. Now, quick question. When I multiplied like bases, I added the exponent. What do you think you'll do when you're dividing like bases? Instead of adding, I'm just going to subtract. So for example here, 4 to the 2x over 4 to the 7 is 4 to the 2x minus 7. So I'm going to put here, divide like bases means subtract the exponents. So if I have 4 to the 2x divided by 4 to the 7, that's 4 to the 2x minus 7. Now convert 64. What is 64 as a base 4? 4 to the 3. And again, you can find it here in your chart. Okay, 4 to the 3 is 64 right here. Then from there, what do I do with my 4s? Cross them out. 2x minus 7 comes down, equal to 3. And then I'll add my 7 across, add my 7 across. 3 plus 7 gives me 10. Divide by 2. And then in that case, x would be what? 5. Good job. Okay, next one. Take a look at it. I have 2 to the x divided by 2 to the 5. How do I combine that? 2 to the x divided by 2 to the 5. What would that be?
That's minus 5.
Yep. Very good. You just take the top one and then you minus the bottom one. Okay? Then 8, convert that to a 2. That's 2 to the what? 3. And you'll just flip back at that chart, look at your base, and then change it. Okay? So then from there, my x minus 5 equals 3 comes down. And then how do I solve with a minus 5? Plus 5 and plus 5. X is 8. You got it. Okay, we'll do one more off your notes, then we'll do one of these off the homework. Look at 22. I need all of those bases to be the same. So look in your 7s chart. What is 49 as a 7? 7, 2 over 7x. And then what'd you say 343 is? 7, 3. So the first thing I do is I make everybody be a base 7. And then when I combine here, do I combine with addition or subtraction? If they're divided, subtraction. And remember, it's always the top one minus the bottom one. But then once you have it in that form, your 7s are gone, you just have an easy equation left over. So I have my 2 minus x equal to my 3. 7's gone, 7's gone. How do I get rid of the 2? Subtract it across, right? Because it was a positive 2. What is 3 minus 2 left over? 1. So I have negative x equals 1. What's my last step? Divide by negative 1, or you can just change the signs. So if it's a negative x here, then a positive x equals negative 1.
Is it supposed to be a plus that is a negative? Or minus 2?
So actually, no, this is a positive 2. It's the x that's negative. So remember, it's the sign in front of the 2 that says if it's positive or negative. Okay? So take a look at your homework. We'll do one of the harder ones off of your last page. So flip over to the back. Remember, odds only. 14? Oh, but that's not odd. You don't have to do that one anyway. Yeah, let's do 11 after. Let's do one with different bases. What about 17? Okay, so look at 17. Remember, you're doing odds only. So no, 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 unless you want to do them for fun tomorrow while you're missing math. Okay, can 32, yes or no? Look at your chart. Can it become a base 4? 32, is it in your 4 chart? No, then I have to go smaller. You can just put it on my desk. So I have to go down to what base? 2. So what is 4 as a base 2? 2 squared. So I have 2 squared with a 5x left over. What is 32 on the bottom? 2, 5. And then what is 16 as a base 2? 2, 4. Then from there, in order for me to get rid of the 2's, what do I have to do with my exponents when they're divided? I have to subtract. So I have 2 to the, what's 2 times 5x here? 10x minus 5. And then 2 to the 4. Does that make sense? So you write everything as a common base. If they're divided, you subtract. And now that I have one base 2 on each side, I can cancel them. So gone, gone. Then 10x minus 5 equals 4. What's my next step? Yep. Add the 5 across. 4 plus 5 is So 10x is 9, last step. Divide by 10. And you can just leave it as 9 over 10. Make sense? Okay. And then which was the other one, Jenna, that you wanted to look at? 11. We can do 11. Okay, so flip back to 11. Last question. Can I do 27 as a base 9? Or are those not compatible? Okay, my 9 chart's right here. Do you see 27 in it? Not going to work. What do I have to go down to then? 3. What is 9? 3 squared? 27 is 3 cubed. So I'll do 27 is 3 cubed. X on the outside. 9 is a 3 squared. 12 on the outside. Now, what do you do when it's a fraction? I don't want that to be a fraction anymore. I turn the exponent what? Negative. So this is going to become 3 to the minus 3 with an x left over. And then that's going to be a 3 to the what when I do the 2 and the 12 together? 24. Now, why am I not adding? They didn't each have their own base. They're already both sharing, then I multiply. Okay, so then from there my 3's are gone. I have negative 3x equal to 24. What do I have to do to solve? Divide by negative 3. 24 divided by negative 3, what do you get? Negative 8. Okay, and then if you want to make a little note here, fraction turns exponent negative. Okay, that's where this negative on the 3 came from, because it was on the bottom and I moved it up and that turned it to a negative. Okay? Alright, you have what? 1, 2, 3, 4, 5. You have like 7 problems left. Yes? Let me look at it. Are y'all good on 11? You said 13? Oh, it would have been a 1. So you would have had 4 to the 2x times 4 to the 1 equals 64. And then when you combined, you would have had like a 2x plus 1. But you don't have to do that one. And then y'all know no school tomorrow for you.